Hello, I'm Dr. Deepthi and we are looking at different concepts from maths under the heading Decreations Mathematics. Today we are going to look at the concept of basis since we have been dealing with several concepts from linear algebra. So what are the basis vectors of a vector space? Now there are certain key requirements. What are these requirements? The set or the set of vectors that you have, all of them should span the whole space. They should be linearly independent of each other and they may not be unique. So if I want to combine these three key properties, I can say that if we are able to write every vector in a given vector space as a linear combination of some vectors which are independent of each other, we can call them as basis vectors for that given space. Now, there are certain terms that you would see here, such as span, linearly independent, etc. Those of you who have been following this channel regularly, you would realize that we have already dealt with these in the previous episodes. For those who are new to this and are looking at this for the first time, let me inform you that we have already done a decreations mathematics episode on span. Similarly, we have done an episode on linear independence, again under the same heading, Decreations Mathematics, and there are also some solved examples for both linear independence as well as span. So those of you who want to revise that, you can go there. Here, I would like to give you a glimpse of those videos. So what is a spanning set? A set of vectors u1 to un forms a spanning set of a vector space V if every vector in this vector space is a linear combination of the vectors u1 to un. And we have even done an episode on linear combination. So there we know that means every vector can be written as a1 u1 plus a2 u2 plus dot 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 an un, where basically a1 to an are scalars that belong to the field. So this is the idea of spanning set. Again, as I said, if you want to revise it, please go back to that episode. Now, this is the first concept of spanning set. We have also seen an example of span. For example, the vectors 1, 0 and 0, 1 form a spanning set for the whole vector space R square. Because you can take any vector AB belonging to R square and you can write it as a linear combination of 1, 0 and 0, 1 in this manner. AB can be written as A into 1, 0 plus B into 0, 1. So for example, if you take a vector 2, 3, it can be written as 2 into 1, 0 plus 3 into 0, 1. So basically they form a span of the vector space R square. Now there's also the concept of linear independence. So the given set of vectors is linearly independent if the vector equation c1 v1 plus c2 v2 plus dot 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 plus ck vk is equal to 0 has only trivial solution, that all the scalars c1 is equal to c2 dot 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 ck is 0, or in other words all the scalars need to be 0 simultaneously. Again, an example was given to you that if v1 is 1 0 0, v2 is 0 1 0, v3 is 0 0 1, this works out. Another example was given for which it works out as well. If you see the previous set of vectors 1 0 and 0 1, these are also a set of independent vectors. So just like here you can see that 1 0 0 0 1 0 0 0 1 form a set of linearly dependent vectors. The vectors 0 1 and 1 0 also form a set of independent vectors. Keep that in mind because we have already shown that it is a span. Now we are also saying that it is linearly independent. So from that it gets a hint that we are trying to prove that 1001 is a basis. This is again an example of showing how to show whether a certain set of vectors is linearly independent. So in a gist, if I want to express the concept of basis in a gist, I would say a linearly independent spanning set for a vector space is its basis. So earlier we had seen that 1001 is linearly independent as well as span. It spans R square or R2 as you want to say. So that forms a basis for R2. What about R3? If you consider a set of vectors 1, 0, 0, 0, 1, 0, 0, 0, 1, these vectors form a spanning set for R3, because if you take any vector from R3, say 5, 4, 9, you can write it as 5 into this first vector plus 4 into second vector plus 9 into third vector. Also, we have already seen that they are linearly independent vectors. That means all the conditions that were required, that means it has to span R cube or R3, the way you want to put it, also that it has to be linearly independent is satisfied. Now the third characteristic we had mentioned that it is not unique. So note that this is not a unique basis for R3. In fact, you can check as an exercise that the set of three vectors v1, v2, v3 such that v1 is equal to 1, 1, 1, v2 is equal to 1, 2, 3 and v3 is equal to 2 minus 1, 1 is also a basis of R3. So you can check it. How do you check it? First show that this set is a spanning set for R3 and then show that this set is linearly independent. If you are able to show it, you are through and you understand what is a basis. So for example, earlier we had shown here the linear independence. So similarly, you have to do it there. But what is the main point that we are dealing with here? The main point is that a basis is a linearly independent spanning set for a vector space. So basis of a vector space is a spanning set consisting of linearly independent vectors. And notice it is not unique. You can have more than one such set. But this, what is shown here, 1, 0, 0, 0, 1, 0, 0, 0, 1, this is the standard basis for R3. Now in the next episode, we are going to look at some more examples of basis, or if I want to use the plural, I would say basis. Till then, thank you.